So these are some of the questions that you can use it for quick review of the functions. The first one is finding the equation of the perpendicular bisector, which joining the point 2, 3 and 4, 7. So first what you're going to do is when you look at the bisector, it is 2, 3 is here and 4, 7 is here. So you're going to find out the midpoint. Midpoint you find out by x1 plus x2 over 2, comma y1 plus y2 over 2. The relevance is you're going to show these working. Don't skip these working. So that will be the midpoint coordinates. So midpoint is basically here. 4 plus 2 is 6 upon 2, which is 3. And 3 plus 7 is 10 upon 2, which is 5. So midpoint is 3, 5. And the bisector is basically going to pass through, by perpendicular bisector is going to pass through this midpoint. Okay, so what you're going to do is now you're going to find out the slope of this line first. So slope is basically 7 minus 3 over 4 minus 2, y2 minus y1 over x2 minus x1, which is 4 over 2, which is nothing but 2. So the slope of this line is 2, and the slope of this line is going to become negative half. So after this, what you can do is you can use either y equals to mx plus c, or you could use y minus y1 equals to mx minus x1, any form, to find out the proper bisector. So now since we know the slope is negative half, so y equals to negative half x plus c. Now I plug this line passes through, the bisector passes through 3 over 3, 5. So 5 is negative half times 3 plus c. So this gives us c equals to 5 plus 3 by 2. So 5 2s are 10 plus 3, 13 over 2. So equation is y equals to negative half x plus 13 over 2. So this is the general solution of the first question. Now question number 2 is where you to find out the domain and range. Now domain and range, what I recommend is that remember that this kind of question you always need to have the multiple approach. Like if you have the transformation skills, if you have got the graphing skills, they all help. And when you want to give the detailed answer, try to write down as many details possible for these kind of questions. So coming to the first one is like when you're talking about root of 5 minus 2x. And so root of 5 minus 2x is basically it's a square root function, and so 5 minus 2x must be greater than or equals to 0, because inside the root it must be 0 or above 0. So when you do that, so you get 5 is greater than or equals to 2x, and you eventually get x is less than or equals to 5 over 2. So that's the domain of this function. As far as the range is concerned, like when you look at the range of this function, is since it is like starting with like 5 over 2, so that's 5 over 2 is x less than 5 over 2. So this becomes the root of this graph. Also, if you equate this to 0 and find out, so 5 minus 2x is going to be 0, so x is 5 over 2. So this is going to be here. Also, you can just quickly check with the y-intercept, which is root 5. And since it's a square root function, and here hence its answer is always going to be positive, so approximate sketch of this graph is like here. So your range for this is y, so domain is x less than or equals to 5, and range is y greater than or equals to 0. And if it is required to write in interval notation form, you're going to write down x belongs to you write down this from, let's say this you open and keep the open interval. So if you keep the open intervals, it will be negative infinity to 5 over 2 closed, and range is y belongs to 0 to positive infinity, and infinity is never included, so that's why you have to keep it open. So any format which is more recommended, I would go for this one for writing your final answer. So that's what is the domain and range of this particular question. So now as far as B question is concerned, negative 2x squared plus 3x plus 5. So again, domain is pretty easy to predict here because it's any polynomial function defined for x belongs to real numbers, which can also be written as minus infinity to infinity. So that becomes the domain for any polynomial function. But it's always good to kind of show the graph and all. Now for range, we're going to need the vertex because the parabola. Downwards facing parabola. So what we do is first find out the vertex, which is negative b over 2a, which will be negative 3 over 2 times negative 2. So it'll be 3 over 4. That's your x coordinate of vertex. And to find the y coordinate, you're going to plug in this here. So -2 times 3 by 4 squared plus 3 times 3 by 4 plus 5. So it'll become -2, 9 by 16 plus 9 by 4 plus 5. So it become -9 by 8 plus 9 by 4. If I take LCM, it will become 18 by 8, and plus 5. If I take LCM, it will be 40 upon 8. So if I simplify this, this becomes 58. 58 minus 9 is going to be 49. So 49 upon 8, that's your y value for the vertex. And approximately, if you go on to sketch this graph, so you got the x coordinate of vertex is 3/4, and y is 49/8. 49/8 is this. It cuts y-intercept at 0,5. So it'll be downwards facing parabola, which is something like this. So you can clearly see the range of this graph is y less than or equals to 49/8. So in interval form, if you write down, it is y belongs to basically -infinity to 49/8 inclusive. That's what will be the range for this question. Now for the C part, it is y equals to e raised to 3x plus 4. Here what we got is, if you look at e raised to x graph, basically it is like this. So e to the power 3x graph is like this itself, y equals to e to the power 3x graph. It's just like with a little bit of stretch factor by 1/3. So e raised to x graph, if you see, is here. And e raised to 1/3, e raised to 3x will become something more steeper, but still will cut at 0,1. And if I move this graph 4 units up by transformation logic, so it basically is there is an asymptote at y equals to 4. This meets at 0,5. So it'll be like something like this. So for this question, this kind of question, that's as I said, that your sketching skill, your analytical skill of transformations will be a very important, like, factor. So here the domain is x belongs to real numbers. So you can say that x belongs to -infinity. So -infinity to positive infinity. And your range is y greater than 4, strictly greater than 4, because it's asymptote. So it'll become 4 to infinity. So you put this, and of course both are open. So that's how you say y is basically y belongs to 4 to infinity. So that's what is the domain and range for this question. So for third question, what we have is y equals to 2x plus 3 over x minus 1. State if the inverse of this function exists with a reason or not. Now, see, algebraically also you can show this question. Graphically also you can show this question, but just wanted to kind of quickly recap the skills that are important. So there is a horizontal line test that we use to check if the inverse exists or not. A horizontal line test is if you draw a function and it cuts the graph at only one point, then the inverse will exist. But if it is not, like here it is not, it is cutting at 2 points, then inverse won't exist. So for inverse to exist, the graph is generally either increasing, decreasing. There is never a turning point on the graph. So if I draw a horizontal line here, it cuts the graph at only 1 point. And in mathematical notation, it is referred as the one-to-one function. So one-to-one function generally will have the inverse. So in this case, let us check, whether it is getting fulfilled or not. So if I draw this graph, now once again here you need the rational function logic. So if I draw this graph at this stage, if I look at x equals to 1 here, x equals to 1 is the vertical asymptote, y equals to 2 is the horizontal asymptote. Then you got y-intercept as 0,3 is the y-intercept, x-intercept is 1, y-intercept is 0,-3. If I plug x as 0, so 0,-3. And x-intercept is -3 by 2, -3 by 2 here. So the graph of this it's here somewhere, it looks like this, and here it will be something like this. So of course you can clearly see the graph is one-to-one function, because if you draw any horizontal line, it doesn't cut the graph at more than a point. But algebraically also you can show this. Like if I generally, like what we do is, if I make x the subject of the formula from here, which obviously will be like finding inverse. So if I say that if I make x the subject, it will be xy minus x. So this is one way to show that this function is one-to-one, hence inverse will exist. But this is the second one that I'm showing now, is an alternative, in case if you wanted to show that. So xy minus xy minus x equals to 2x plus 3. I basically multiplied this. So this is actually y, xy minus y equals to 2x plus 3. Now make x the subject of the formula. So if I make x the subject of the formula, it will be xy minus 2x equals to y plus 3. So if I take x common, you get y plus 3 over x minus 2. So here, if you look at y minus 2 here, so if I take any one y value, let's say I pick a y as 4, you will see that there is always only one x value. And of course, this is something which you need to understand, like as a core of the basic of the function, like in a logic where like vertical line, horizontal line test. So at the end of the day, I think any one of the reasons should be justified. That's what is the that's what will tell that this for this function your inverse exists. Now, as far as finding the domain and range is concerned, as we saw the graph clearly that there was a vertical asymptote at x equals to 1, horizontal asymptote at y equals to 2, and there's a graph like this here. So in this case, your domain will be x belongs to real numbers, x should not be 2, x should not be 1. So y belongs to real numbers and y should not be 2. So this will be the domain and range for this particular question. The next step is find out the inverse of the function and its domain. So obviously inverse function, you interchange x with y. So this is going to be here. So it'll become xy minus x equals to 2y plus 2, 3, and make y the subject. So xy minus 2y equals to x plus 3. So now if you take y common and divide to the other side, it'll be x plus 3 over x minus 2. Now, of course, here the domain is x belongs to real numbers, x should not be 2, which is basically the range of the original function. So domain is range and range is domain. Second is find out the point of intersection and its intersection of function and its inverse. Logically, if you look at the inverse and its function, wherever they intersect, they'll intersect along y equals to x line. So for example, if my function is like this, if my inverse I'm drawing, it has to be something like this. So any intersection that will always happen along y equals to x line. So there are two ways you could do this, that you found this inverse, you found this function, you just equate them and you solve for x. That's one way. Or you could just replace this y with x, because you know that along that line itself, they're going to meet. So you can save some time by doing this. And this is also another required skill. So some questions, if you don't know the skill, you might not be able to solve. So you'll get x squared minus x equals to 2x plus 3. You get x squared minus 3x minus 3 equals to 0. Then you solve using quadratic formula. So this becomes b, x equals to b, which is a negative b. So it'll become 3 plus or minus root of 9 b squared minus 4ac minus 4 times 1 times negative 3 upon 2a, which is 1. So it'll become 3x equals to 3 plus or minus root of 9 plus 12, because minus must become plus, and 9 plus 12 is 21, root of 21 upon 2. So these are the two intersections that this function and its inverse will have. Now here, fourth and fifth question is basically state if the following functions are one-to-one or many-one with the clear sketch. Also, with the largest restricted domain, where will the inverse of the function exist? So what we're going to do is I'm going to use, instead of calculator, I'm going to use, let's say, Desmos for this. I'll just go on to Desmos now. So here the questions are like stated with the reason whether the function is one-to-one or many-one, with the clear sketch, also with the largest restricted domain where the inverse possibly exists. So first one which I'm taking is x minus 1, x minus 2, x minus 3, x minus 4 from 0 to 4. So I have already plotted these graphs here on Desmos. So the first graph is x minus 1, x minus 2, x minus 3, and x minus 4 from 0 to 4. You can see here. That's the graph that comes is like here. So obviously you can see the graph is not one-to-one function. Okay, so clearly for the given domain also it is not one-to-one function. And so because obviously it fails the horizontal line test, number one, you can see clearly it fails here. So what we do is, now next part they're saying is that where will the inverse exist? Now for inverse to exist, you have to make the function 1 to 1. So either I can restrict the domain from, let's say, 0 to this minimum point, x between, let's say, 0 to minimum point, which is, if I find out, it is nothing but 1.382. I'll just write all the coordinates. So this coordinate is 1.382. So that's one thing I can take, or I could have taken was from basically here to here. I could have taken the restriction from here to here. So which is 1x between 1.382 to 2.5. And the next one is from 2.5 to, I could have gone to 3.6. So whichever is the largest that you got to take. So whichever is the largest domain out of these, you select that as your answer. Out here, the largest domain that you have is 0 to 1.382. So that's what we will take for our final function. So also you can just check, like, whether it is becoming 1 to 1 or not for this domain. So what I can do is I can now cut down, let's say, the domain instead of 4, if I take 1.382. So you can clearly see that the graph is actually now 1 to 1 function, or you can see it as like it is going to have inverse for this. Similarly, for the next one, what we have is the cos x graph. Now we have cos x graph. They have given the question is 0 to 2 pi sketching. So if I go from 0 to 2 pi, you can see that this is not 1 to 1 function once again. So I can cut down until this point. So I can take the domain from, let's say, 0 to pi. If I take this domain, which is 0 to pi, that becomes my largest domain. And also the graph will have the inverse for that particular range. So if I, instead of 2 pi, if I can show here that this is, let's say, pi, you can see that the inverse will exist. So this is the second solution for here. Now coming to the third solution, which is the last question, is x cubed minus 4x squared plus x minus 1 from -2 to 5. So I wanted to find out whether the function is 1 to 1 or not. Again, you can clearly see that this is not 1 to 1 function. So what we can do is we can restrict the domains. We can so that there is a turning point here. There's a turning point here. So we can restrict the domain from 2.5 until 5, or you can take 0.1 to 2.5, and whichever is like from -2 to here. So out of this, whichever is the largest domain that you take as for the question that they have specified. When you are looking at these critical, like the domains, I think the largest domain that you'll get will be this one until 5, because this one from 0.131, this is slightly bit smaller, maybe by decimal place. So you'd select this domain for as the largest domain for the given like inverse. Now for the fifth question, what we have got is solve the following equation using GDC. So since we have got two of the functions here, so we're going to just make y the subject to the formula before we go on to solve them. So you do 5y equals to 1 plus 3x, y is 1 plus 3x upon 5, and here will be y equals to 6 minus 5x upon 4. So you plot now both of these functions. So you plot both the functions on your calculator, and then you see where they are intersecting. So let us just go on and plot both the functions on our calculator. We already made, let's say, y the subject here. So it'll be 1 plus 3x upon 5. And here it is y equals to 6 minus 5x upon 4. So you're just going to plot these two graphs on your calculator. So let's say if I just go on to the graph here now, plot the graph. So 1 plus, let's say, just go on to here and plot 1 plus 3x over 5. And second one is 6 minus 5x over 4. So once we plot this, I'm just going to remove the last graph. So you just see where they're intersecting. So the intersection that comes is x is 0.7027. That's your x coordinate, and your y coordinate is 0.6216 to 4 decimal places. Generally, they expect the answer to 2 decimal places. So that's how you do this kind of question. So this is here when you look at like the two functions and you want to see where they're intersecting or where they are like basically like when you want to solve the equation graphically, you have to do this approach. Plot the graphs and see where they're intersecting. So when you're looking at the second one, what we have is we have got 2x squared minus 3x minus 4. We have to equate to 0. We have to solve for equals to 0. So you first plot the graph. Make sure you got the view window right, like just get the view window so that you can see the graph at least. And remember that this working, this is referred as a working. So you've got to copy and paste the same graph at your, on your like answer sheet. So first you draw the graph, like for example, if I draw here, so this point that comes is negative 0.850, and this point which you get the second coordinate where it is 0. So you do G solve, basically G solve and roots. If you get the G solve and roots, you get both the answers. So first answer is that, and second answer is 2.350. So these are the two answers for this particular question. And this graph needs to be shown as a working. So the last one is we got to do e to the power x, which is you press shift and ln to get here. E to the power x minus sine x, which is plus sine x. So plus sine x, I'm going to do this plus sine x and minus 2 equals to 0. So you're going to just do this. And of course, we don't see any other intersection at this side. Only there is one other root that you can see, and you do G solve intersect. G solve roots. So G solve press roots, you can see the intersection, that is 0.44. So that's only one of the solution for this particular question. And copy this as a working. For question number 6, what we just got to do is we got to draw the graphs and see where they're intersecting, just like your GDC skills they're testing. And what we're going to do is first let's plot this graphs on calculator. So I'm just going to take the first set, so which is 2x minus 1. So here I'm going to show, so 2x minus 1 and 3x squared minus 7x plus 1. So these are the two graphs that we have got, and now just execute. You can see the two intersections. Plot these graphs as a working on your like in your answer script, and just press G solve and intersect. So the first intersection that you see is 0.241, and the second intersection is 2.758. So these are the two intersections that you're getting for this particular question. The next question is to find the intersection of e raised to x plus 1 and y equals to x. So you're going to change this function, and second function is e to the power x plus e to the power x plus 1. And just you look at this, so there are no intersections. So e to the power x plus 1 and y equals to x, they're not intersecting at any point. So that's, you'll see the no solution. And third one is sine x and 3 to the power x minus 2. So sine x and 3 to the power x minus 2. So sine x here and 3 to the power x, 3 to the power x minus 2. So this is the, here you can see that there is one intersection at least. So you press G solve and intersect. So you got the intersection at 0.93 and 9. That's what you're going to write down as your working. So you're going to draw both the graphs and see, mark this point as intersection. That becomes the working to support for this particular question. So for our 7th question, what we have is we've got y equals to 1 over 4x squared minus 1, y equals to e to the power 3x minus 3, and y equals to 5x minus 6 upon x minus 2. So we got to show all the critical features of the graphs. Now, obviously, the first one you have got is 1 over 4x squared minus 1. So let's just do this one first and see what are the important features of this particular question. So when you put this on calculator, 1 upon 4x squared minus 1, you can, when you execute, you can see graph like this. And so first you do one thing is you're gonna, ideally, if you look at like, if I have to draw this graph, I mean, you can use reciprocal function logic, but there are two vertical asymptotes. If I equate 4x squared minus 1 to 0, I get x is negative half and x equals to positive half. So there are two vertical asymptotes. So there are two vertical asymptotes that also are visible on the graph here. So x equals to half and x equals to minus half. Then you have this side is y equals to 0 as the horizontal asymptote. This side graph is something like this, and this side the graph is something like here. X-axis the horizontal asymptote, and of course the turning point. If let's do, if I find out G cell max, if I do that, I'm getting at 0, -1. So there is a maximum point at 0, -1, local maximum. So this is the point that we wanted to show. So this is going to be the graph of this particular question. Let's go to the next one now. We have the two more graphs left for this part, which is e to the power 3x minus 2. So what we're going to do is e to the power 3x minus 2. So draw y equals to -2 line, which is the horizontal asymptote here. So it's going to be something like this. You're going to mark the x and y intercepts. So I'm just going to first show some of the critical features of this. So this is the graph. Do G solve your roots. So you'll get the root as 0.21. So this is 0.21, 231. Then you find out the y-intercept, G solve y-intercept, which is at -0, -1. This point is 0, -1. And obviously y equals to -2 is the horizontal asymptote for this particular part. So this is the graph of second part. And now let's do the last one, which is a rational function. Basically, I'll just deselect this, I'll select this. So you get now something like this. So the equation is 5x minus 2, which we got first right on that equation. 5x minus 6 upon x minus 2. So 5x minus 6 upon x minus 2. So you can see that straight away vertical asymptote is x equals to 2. Horizontal asymptote is y is equals to 5. And now when you're doing the final sketch, like you got to show the roots and y-intercept as well. So G solve roots. If you do, you're going to get at 1.2. So root is at 1.2. G solve y-intercept when I do. G solve y-intercept. So you get 0,3. This is 0,3. So you are going to draw now vertical asymptote at x equals to 2 here. X equals to 2, and horizontal asymptote at y equals to 5. So graph is something like here, like this, and it will be something like this here. So that's how you draw this graph, and like these are calculator skills. The next one is find out the domain and range for root 2x plus 5. So if you look at root 2x plus 5 graph, it cuts here at -5/2, and this is how the graph of this look like when you use technology. This will be at cutting at 0, root 5 basically. So domain for this is y greater than 0, and x belongs to, x less than or equals to -5/2. So more than -5/2. So this is more than or equals to -5/2. Find the inverse and state find if the inverse exists. Yes, it will exist because 1-to-1 function and pass horizontal line test. Find the inverse of this function, state its range. So inverse of this function is going to be y equals to 2x plus 5. If I interchange x with y, so it'll be x squared equals to 2y plus 15. So y is x squared minus 15/2. And that's this point. And now the range of this, state its range. So range of the inverse is domain of the original function, which is, so y greater than or equals to -5/2. So that becomes the range of its inverse function. Find the point of intersection of the function and its inverse. So as you know that once again, the function and its inverse intersect along y equals to x line. So you do y equals to root 2x plus 5. You just replace this y with x. So x will be root 2x plus 5. So x squared is 2x plus 5. So x squared minus 2x minus 5 is 0. And this, we can solve it and find out the exact value. So here, if I draw using quadratic, solve using quadratic formula, I'm going to get something like this. The graph will be something like here. So you can put in the quadratic formula and you can get this answer should be 2 plus or minus. Since we are just taking positive value here, so 2 plus a root of b squared, which is 4, minus 4ac. So 4 times 1 times -5. So it'll be 20 plus 20 upon 2. So it'll be 2 plus root 20 or 2 plus root 24/2. So that's the intersection point. If you want to get exact value of decimal, you can use calculator. And then finally sketch the graph and the function on and its inverse on the same axis. So we got this part, which is basically the reflection in y equals to x line. You got to specify that. Now let's just do the same thing on like calculator as well. Let's see how we do this on technology directly, entire stuff. You can see here the graph of this is the original function. And now if you can just sketch gsolve, I mean, you can see the roots, whatever we discussed, so that part is here. And you can also draw y equals to x line here to just see that there are inverse, there when you do sketching inverse function. If I sketch the inverse, you can directly see that there are this is how the green line is the inverse, and do gsolve and intersect to get the exact coordinate, which is 3.44, which you should get as the intersection coordinates.